wondering what kind of complex and sophisticated technology that they used. What do you think were their means of technology? Obviously, there was no phones during that time. So how then did they manage to transfer messages from one person to another? What was their idea behind? The answer to this question is simple. They were just basic concepts of linear algebra. Specifically, something as simple as the inverses of matrices. So for now, let's sit and relax and watch a short video of how they used encoding and decoding to win against their opponents.
September 1939. As Britain declared war on Nazi Germany, an extraordinary motley army was being assembled at Bletchley Park in the English countryside near London to fight a secret war. Their mission was to crack one of the hardest codes ever devised, created on a machine called Enigma. Enigma lay at the heart of Hitler's armed forces communications system. Two of this elite were the renowned mathematician Alan Turing and the dean of a Cambridge college, Gordon Welshman.
Gordon Welshman was actually quite glamorous. He was good looking and he knew he was good looking. He had a way with the ladies. He was fantastically bright, very pugnacious, obviously a very proud man.
Welshman was one of the original elite codebreakers, given the Herculean task of decoding the Enigma machine. Enigma used a combination of rotors, plugs, and wiring to put German messages into secret code. There were 1 in 159 million possible combinations. While others sought to crack the codes, Welshman took a different approach. Instead, he focused on what would come to be known as traffic analysis. The body of the message was unreadable, but the first few letters and numbers were not in code. This was the call sign, the address, identifying who the message was to and from. There was crucial information in the call signs, and Welshman started to track it, linking up who was sending and receiving the messages, where they were, where they went. It was a brilliantly simple observation, yet it would prove crucial.
They call it chat that comes over the air. And by this means we can build up a picture of a German unit, the headquarters, any outstations it has, and how they keep in touch with each other and send messages.
Just using traffic analysis, Welshman started to reveal the precise enemy forces that faced the Allies. Modern code breaking was born.
And they had a big wall map, and you could visually see the whole setup of the German communication system.
Traffic analysis was Bletchley's first major breakthrough.
Without an analysis of traffic, you would never have been able to use cryptography to win the war.
So now that you have understood how encoding and decoding were used in World War II, let's now take you into the deep understanding of how it is really used.
Encryption and decryption. Encryption came back around 400 years ago. There is a historical account that the Egyptians, Chinese, Indians, and the Greek used to encrypt messages in a way for various purposes. One of the famous scenes of encryption is referred to as the Caesar cipher. It was invented by Julius Caesar and was later substituted by a substitution cipher. How they were used in encoding messages was the interchanging of the letters in the alphabet. For instance, substituting F by D, K by H, and many more. According to research, it was unveiled that those ways of encrypting messages are not secure today. Also, it has been in the record that the European nations were using such encryptions. Or, for instance, the majority of them were used during the Second World War, that's World War II. The military military was sending messages in an encrypted form in order to carry out military operations. This kept their information safe from their enemies. As a result, most of the other countries were spending a lot of resources to decrypt such messages. The encryption using matrices multiplication was discovered by Lester Hales, a professor in mathematics. He was involved in the United States military encryptions. His algorithms are now the basic theory of modern mathematics in the field of cryptography. In this modern day, some modern methods of encrypting make use of matrices as a crucial part of their coding and encoding of their secret messages. Below illustrate the various pedagogies in encrypting and decrypting secret messages using matrice and its inverse. Methodology for encryption and decryption, that is encoding and decoding. Before we talk about the encryption processes, let us briefly look at how we find an inverse of a matrix. To find an inverse of a matrix, we need to find a determinant and an adjoint of the given matrix. Let us consider the 3x3 matrix below, which is A equal to the matrix. To find the determinant, we need to find the minus and the cofactor of the given matrix, as illustrated. In this case, you need to go to a particular algebra, and illustrated on the board is the algebra that you need to go through in order to receive or get the determinants of the matrix that we are talking about. In this case, the determinant of our matrix that we are using is A equal to 49. Now, let us consider finding the adjoint of a matrix. Consider the 3x3 matrix below. In finding the adjoint of the matrix, we must first find the minus of the matrix, which has been named A. In doing so, we must find the minor Mij of an element Aij, where I is the row number and j is the column number. We will cover the row and the column of the element and find the determinant of the remaining square matrix, which has been illustrated below. Now, in finishing up the minus, we have a new set of matrices, which has been illustrated below. Then to find the adjoint, we will multiply each element of the minor matrix by each element of the cofactor as illustrated in the box, and then take the transpose of the resultant matrix. Finding the adjoint of a matrix. Now, adjoint of our A is an adjoint of A equal to 8, 26, negative 33, negative 5, negative 7, 17, 3, negative 12, and 13, which is the transpose of the cofactor matrix as illustrated above. Now, let's find the inverse of the matrix A. The formula for finding an inverse is equal to one of the determinants of the matrix multiplied by its adjoint. Now, our inverse is equal to 1 over 49 multiplied by the adjoint of the matrix. Methodology for encryption or encrypting. Now that we have briefly explained the concept of determinants, adjoint and inverse, let us now go straight to encryption processes. Now, we wanted to convey a message to our colleague, and that message that we wanted to convey is called access data. Let us assign numbers to the various alphabets as illustrated. It can be small alphabet or mixed, but in this case, we are using only uppercase letters in this experiment. The method has been illustrated below. You have to assign each letter to the number as illustrated in the table previously. To do this, we group the secret message into 2 if you want to operate in 2x2 matrix, or into 3 if you are going to operate in 3x3 matrices, and in any other matrix dimension form, and assign their corresponding numbers from step 1. In this case, we are using a 3x3 matrix for illustration using the message access data. Now in step 3, we form a matrix with the corresponding vector numbers of the message. In this case, we have our matrix A, which is equal to, in row form, 1 5 0 20, 3 19 4 1, and 3 19 1 0. Now let's move to step 4. In step 4, we must get a compatible matrix. That is a matrix with inverse or non-singular matrix that has the same number of rows as the matrix of the message A column. In this case, we have our compatible matrix, which has been illustrated below. Another step, we need to multiply the compatible matrix by the message matrix, which is A. Then we obtain our resultant matrix, which is C. And the resultant matrix is 7 53 5 21, 4 34 1 20, 8 58 5 41. Now we can clearly observe here that C is our encrypted message access data, which is saved for us to send with the formula of encryption B.A equal to C. Now we are done with our encryption. Let us move straight to the methodology for decryption or the decoding of the message. Let's assume that the matrix C has been sent to us together with the compatible matrix. Let us decode matrix C and have access to the information delivered. Now B was used to transform A to get C. Therefore, considering the formula B.A equal to C, we have our A equal to the B inverse multiplied by C. Now step 1, we must pick the compatible matrix, in which case we call it transformation matrix, B, and find the adjoint using the illustrated method, as already discussed. In that case, we have our B equal to 1 1 negative 1, 1 0 1, 2 1 1. And we are going to use this compatible matrix to decode our message matrix. Now let us move to another step in step 1. Here we must find the inverse of the matrix using the formula above, B inverse equal to 1 over determinant of B multiplied by its adjoint. Therefore, our B inverse has been stated as negative 1 0 1, 1 negative 1 0, 1 1 negative 1. Then, having our message matrix, which is C equal to 7 53 5 21, 4 34 1 20, 8 58 5 41. Decoding our message matrix using the formula A equal to B inverse multiplied by C, you have our A equal to negative 1 0 1, 1 negative 1 0, 1 1 negative 1, multiplying by our message matrix 7 53 5 21, 4 34 1 20, and 858,541. In this case, we are obtaining a new set of matrices which is A, and is equal to 15020, 319, 41, and 319, 10, which is the same as the matrix we started with during our encryption process. At this juncture, let us try and get out our secret message using the secret matrix. So at this stage, we then take each column of a matrix A and align them with their corresponding letters as illustrated in R1 to get the decoded message, which is access data. Now let's talk about a research paper from an international conference on information communication technologies, a novel string matrix data structure for DNA encoding algorithm. DNA cryptography is a rapidly developing field of DNA computing research that aims to provide invincible cryptographic techniques for today's modern cyber world and the future DNA computers. Several DNA-based cryptographic algorithms for encryption, decryption, and authentication, among other things, are proposed. The first and most important step in DNA-based encryption is the plaintext encoding. The main limitation of DNA encoding is the lack of an effective, randomized, dynamic, and secure DNA encoding techniques for plaintext DNA encoding. This paper describes a novel DNA encoding algorithm that overcomes this limitation. This encoding algorithm is based on a novel string matrix data structure for generating unique DNA sequences that can be used to encode plain text as DNA sequence. The experimental and comparison results show that the proposed DNA encoding algorithm outperformed the existing DNA encoding algorithms. Secure communication is essential for facilitating the confidential exchange of information between the sender and the receiver. With the internet increasingly serving as the medium for all banking and electronic commerce transactions, it is critical that the communication is made highly secure. The first step in any cryptographic algorithm is the DNA encoding of the plaintext. The plaintext is encoded into DNA sequence using the DNA alphabet ATCG. This would allow the given message sequence to be encoded as a DNA sequence, which the DNA-based encryption algorithm will then act on. String matrix data structure and their operations are defined in order to generate this table. The subsequent section describes how to use this data structure to generate the DNA encoding table. So in all, in bringing everything to an end, let's summarize what we learned from this video. First of all, we find the determinant of a matrix. We found the adjoint of a matrix. Also, we learned how to find an inverse of a matrix, and also learn how to decode and encode of a message using the matrix. And last but not the least, we discussed a research paper which makes use of matrix and its inverse as an application in a DNA encoding and decoding. So I know and believe that you were able to grab something better from watching this video, and I am hoping to meeting you in the near future. Thank you.